All right, we are in Chapter 2, Section 4, called Solving Equations with the variable. I believe it's on both sides. Oh, I had another screen behind there, but I believe it's on both sides. So this is the basic way I've been starting all these videos off, just showing you the screen, the same screen you will see as a student, with the exception of a couple of little pieces. So I don't see a due date on mine. You will see one on your student side. They just don't give me that on the teacher preview. Attempts, I'm in attempt number 1, so it just depends on what attempt number you're in. And then of unlimited. You can come in here as many times as you would like and try the assignment and submit it. So there is no limit to that. The number of questions on this assignment is 10. It's going to be anywhere from 1 question to 10 questions. So it just kind of depends on the assignment there. Grading policy is always best score, so whichever attempt is your best is the one you keep. And partial credit, meaning that if you answer 1 of 10 questions, we give you credit for the 1 question. Always remember to submit your work. So once we click start here, on your student side, this is a second piece I don't see on my screen as a teacher, but on your side, you will see a submit assignment button down here in the bottom right corner. Always hit that button, even if you've only answered 1 of the 10 questions. Number 1, it tells us you've been working on it and how far you got. So we know what your grade is on there, and we can even see how you've answered. Number 2, it will stop the system from locking you out of all other assignments. If you don't click the submit button and you just say, hit the red X here to leave, or on your screen you'll see the home menu button here, well, then it's going to lock you out of everything else. You will not be able to do any other assignments, quizzes, tests, topics. Nothing will be clickable until you come back in here and hit submit, okay? So always, always, always hit that submit button. On the right side here, you will see always these 3 buttons. You may also see a calculator from time to time. This is the explanation button. It tells us we're going to lose our attempt on this question because it's going to explain this exact question to us. So it's not going to give you the answers and then have you come and type them in. It's going to show you how to do it, which is a really cool feature because maybe you've looked at the example here, which is a general example, and this problem just looks a little different and you're not sure how to do it. Well, you can get the explanation and say, oh, okay, I see what they were doing there, even though it was a little different. And you can come in on another attempt and try this problem. If you click example, that does not take anything away. It just opens up a new screen within here. So I can see I have to scroll back and forth because I have the screen minimized. But it shows us a problem just like what we're looking at and explains, okay, we want to go through and do these pieces. So this is an important part here for this explanation. And I haven't explained the problem yet, but what it's doing is it's giving us this equation. It's going through and solving it for us, and we have to choose the steps. Why did we do these things? Or what did we do in this step to get from, the last one to this one? We have to justify it with a reason. So we're going to use our properties that we learned back in Chapter 1. So we have the distributive property, which means, I'm multiplying by everything in the parentheses. So A times B and A times C, and I add those 2 together. Or if it's on the end, means the same thing. I'm still multiplying by the number outside the parentheses. We have addition property, which means I can add the same thing to both sides. So I had A equals B, now I have A plus C equals B plus C because I'm increasing it by the same amount on both sides. So that's addition property. Subtraction property, same idea. I can decrease something by the same amount. Multiplication property, I'm increasing again, but this is I'm going to multiply both sides by the same thing. So it's not just a simple increase of addition. I'm actually multiplying on this one. But again, I can multiply by the same thing on both sides. And then division property. I can divide by the same thing on both sides. So these are the properties we need to choose in these drop-down lists. So sometimes you will need to click on explanation just to get that little background, that explanation. If you don't understand what the properties are, you need to either look them up or use the explanation button, and it should generally give you an example button. So it should potentially give you an example of all these properties. If it doesn't, that's when we have to utilize other resources to look them up real quick. So once we're ready and we say, okay, I understand they want me to, pick the correct one in the drop-down menu, and you can see some of these are simplification, meaning they're showing the property happening, and then they went ahead and actually completed the property. 6 divided by 6 cancels. 3 times 6 is 18. So all they did was simplify that property. So we click simplifying there. I can close that. If I want another example, I can click on example, or I can also message my teacher with this question attached. Okay, so now that we've looked at the example for this problem, we know what we need to do here. We're given an equation, and it says solved in several steps below. For each step, choose the reason that best justifies it. So here, this is the given equation, and they even say given equation. That's what we start with, given. The second part here, well, now I can see the equation along the top here. It's the same thing as step 1, but now I have this divided by 6 divided by 6. So I'm dividing both sides by 6 here, because that's how we would solve, that's how we would get rid of this divided by 6. You can distribute it, but you can also divide it away to the other side if you don't want to have to do the distribution. That's another option. We tend not to do that. When I'm doing it in class, I know I tend to do the distribution, but you can also divide it away if you want to. So this would be the division property of equality, because I'm dividing 6 on both sides. Well, now 6 divided by 6 is 1, so u minus 1 just drops down. I don't have to have the 1 there anymore in front. Negative 18 divided by 6 is negative 3. So all I did to get from step 2 to step 3 was I simplified. So we choose simplifying. Now I can see u minus 1, and then there's this plus 1. And I can see negative 3, and then there's this plus 1. So I'm adding 1 to both sides, because there's this minus 1. In order to get u by itself, in this, if I look at step 3, well, I want to look at what's being added or subtracted, and I want to do the opposite of that. So I'm subtracting 1, so I'm going to add 1 to both sides here. So I'm going to look for the addition property of equality, which says I can add the same thing to both sides. It doesn't change the equation. I'm just moving things around. So now if I actually simplify this, negative 1 plus 1, that cancels out. Any number minus itself goes down to 0. And so u just drops down by itself, and then I have negative 3 plus 1. I have negative 3 plus 1, if we think about, and I like to draw my little number line here. We have 1, 2, 3. There's negative 3. This is my plus direction. This is my minus direction. I want to go plus that to the right, 1 space. So remember, if this is 0, then I need to get closer to 0, so that'd be negative 2. So I really just subtracted those. Negative 3, or 3 minus 1 is 2. There's more negatives than positives, so it's still going to be negative 2. So really, all I did there was simplify. All right, so this is just about thinking about why am I taking these steps? How do I know to go from step 1 to 2 to 3 to 4 to 5? What are we doing in each one of these steps? All right, so now we are actually going to try this guy out, and we're going to solve this. So we have 7v plus 17 minus 12v equals negative 38. So before you start moving things around, go through Pemdas. Make sure that you don't have any parentheses, that you don't have any exponents, that you don't have any multiplication and division that you can actually deal with, because we can't actually multiply 7 and v. This is how we have to leave it for now. Same thing with 12 and v. Or addition and subtraction that we can deal with, meaning, are there some like terms we can combine? And in this case, I have 7v and I have 12v, or negative 12v. They both have a v, which makes them like terms. So we want to go 7 minus 12. So again, if I like my little number line idea here. So I have 0, and I have, oops, and I did that funny. 0 should be in the middle here. 1, 2, 3, 4, 5, 6, 7. There's 7. And remember, this is my minus direction, this is my plus direction. So I want to take 12 away. I'm going to go to the left 12 spaces. I'm going to subtract it. Well, I only have 7 to take away to get to 0, but I need to get up to 12, so I need to go 1, 2, 3, 4, 5 more, and that's in my negative. So negative 5v plus 17, because 17 didn't change, and neither did negative 38. All right, now we can start to solve this guy. We've gone all the way through Pemdas. So first, we say what's being added or subtracted from the same side as a variable. This negative 5 is not being subtracted, it's being multiplied. So be careful about that. 17 is the one being added. So I'm going to subtract 17 from both sides, and this is the subtraction property. I can subtract the same thing from both sides, and I'm not changing the equation. Again, I'm just moving things around so that I can get v by itself. So negative 5v, 17 minus 17 cancels out, and negative 38 minus 17. So this means if I'm looking at a number line, I'm already negative 38, and I'm going to pretend like this is 38. I know that's not, but if we had negative 38, I'm going to go more negative. So that means I need to add these guys together and keep my negative sign. So I get 15 there, 3, 4, 5, so I get 55. Negative 55. Now, this is the simplification that we did on the last one. So this would be simplifying. Second, or I think this would be the fourth step, because we had to also combine like terms here. We're multiplying by 5 here, so the opposite of multiplication is division. And yes, I need to take that negative, because we don't want to leave the negative with the v. I want to take the entire negative 5. So negative 5 divided by negative 5 cancels down to 1. I do not have to write 1v, just v. Equals negative 55 divided by negative 5. Two negatives make a positive. So now I know that's going to kind of go away. It's going to become positive, so I can just focus on 55 divided by 5. Well, I can even do this mental math, because 5 divided by 5 is 1. 5 divided by 5 is 1. There's nothing left over when I do those divisions, so it's going to be 11. All right, we're going to keep going here. Go back to blue here, so we have 2w plus 9 equals 8w plus 21. So here's our first real situation where we have a variable on both sides of the equation. So remember, whenever we have multiple occurrences of a variable or of a constant, meaning just a number, we want to bring those together. Those are like terms. But if they're on opposite sides of the equal sign, like they are here, so I'm going to draw my dramatic little dotted line. I know I don't do this too often, but here's my two sides of my equal sign. So I can't just say 2w plus 8w. To bring them together, I'm going to have to subtract 1 to the other side. They're both positive, so both of them are going to require subtraction. So it doesn't really matter which one I choose. I just have to choose one. So I'm going to go ahead and choose 2w, and I'm going to subtract 2w from both sides. So now I have 2w minus 2w. Any number minus itself cancels out. 9 equals 8w minus 2w. You get 6w plus 21. All right, now we want to bring our constants together, although this is looking much more like, just a two-step equation now. What's being added or subtracted the same side as the variable here, the w? Well, 21's being added, so I'm going to subtract it. Like that. So now I have 9 minus 21. Remember, if we're thinking of our number line here, if I have 9 all the way over here, and I want to subtract 21, that means I'm going left on my number line. I can take 9, but then I'm going to have to go to the negative section for the rest of those, right? So, or you can just think of it as subtraction. 21 minus 9 will get you 12, right? And it's going to be negative 12. There's more negative here than positive. I have 21 negatives and only 9 positives. So we're definitely going to be farther over here on the negative side. It's going to be somewhere like that, like negative 12. So I have 9 and then 12 more. That's 21 that I took away from 9. Equals 6w, because that just drops down. 21 minus 21 cancels. So now we need to deal with this multiplication division step. So I'm multiplying by 6. I'm going to divide by 6 on both sides. 6 divided by 6 cancels. And we have w equals negative 12 divided by 6. Well, a negative divided by a positive is going to be a negative, so 12 divided by 6 is 2. It doesn't matter that it says w equals or negative 2 equals. It's still the same thing to say w equals negative 2 or negative 2 equals w. That's a symmetric property. I can flip those around as long as the negative doesn't, somehow flip around or drop away. We're just literally mirroring the image kind of a thing. All right, let's go ahead and keep moving here. Okay, so now we're getting more steps. So each time we move to the next problem, we're given just a little bit more that we have to complete here. So first, simplify. We have to go through Pemdas first. So parentheses, we do have parentheses here. So I need to take this 3 and multiply into the parentheses here to get rid of it. I can do that division step that we saw on number 1, but remember, if I do that division step, I'll take a step back and show you. If I divide by 3, it's everything divided by 3, not just this piece, but the 6v also. So that's where it gets a little bit confusing when you have more than one term on the side. You have to make sure that you multiply everything or divide everything. But if I just use distribution, I don't have to worry about that piece. All I have to do is distribute 3 to the parentheses here. So I can go 3v, and then 3 times 2, we get 6, minus 6v. This does not get multiplied. It's not within the parentheses. And then 24 also does not change. So now, before I move forward, I need to look for some like terms, or before we got to like terms, because that's addition, subtraction, we'd have to make sure we didn't have multiplication, division. Sorry, I skipped over that without saying it. We don't have any that we can actually solve right now, because the distribution was kind of our only multiplication step. To get rid of the parentheses, we had to multiply. Now I do have some like terms, though. I have 3v and 6v. So you can use the number line if you really like that. Otherwise, just remember, if they're opposites, positive, negative, you're going to subtract. And whichever one is bigger tells you what the sign is. So there's more negative than there are positive. So it's going to be negative 3v plus 6 equals 24. All right, now we're simplified as far as we can go. We added our like terms. So now we're going to start to solve. I'm going to switch my colors again here. So what's being added or subtracted on the same side as the variable? 6 is being added. So I'm going to subtract it like this. And I have negative 3v, 6 minus 6 cancels, 24 minus 6, and we get 18. And that one's usually pretty easy. 24 minus 6, students don't tend to get as confused with that one because it's kind of more basic looking with the subtraction. They don't have to worry about the positives and negatives so much. So now we're going to look at the last piece here. I'm multiplying by negative 3, so I'm going to divide by negative 3. Don't forget to take the negative. We don't want to leave that negative behind. So negative 3 divided by negative 3 cancels out. It becomes 1. I don't have to write 1v, just v. 18 divided by negative 3. A positive divided by negative is going to be a negative. 18 divided by 3 is 6. So in this case, it has to be 6. All right. Uh-oh. Oh, did I forget to type in my negative? I did. So, and another thing, if you do get it wrong, it's not going to immediately say, nope, you're wrong, you don't get to try again. It's going to say, incorrect, your answer is incorrect, try again. So it'll let you try it again. It'll show me that you've tried more than once, but that's okay. You still get the same number of points there. So it's just kind of letting me know that maybe you stumbled a little bit. But do mistakes happen to everyone? Of course they do. Everybody makes mistakes. That is super normal. In fact, it's part of the learning process. If we don't make mistakes, we're not really learning anything. We must have already known it if we don't make any mistakes at all. So, and even if we do know it, sometimes we still make mistakes, right? All right, 2v minus 48. So this one, we're starting, to kind of, it's a little repetitive on this one so that we can practice a few of these, because the more we practice, the better we will get at a certain type of problem. So with this one, we have our parentheses. That's the first part of our PEMDAS. So we want to do this distribution here. 6v, or 6 times v is 6v. 6 times negative 4 is negative 24. Equals 2v minus 48. Nothing happened to this right side here. And now we don't have any multiplication, division we can actually deal with in simplification. We don't have any addition, subtraction we can deal with in simplification. So we're going to move to solving. I have a variable on both sides of the equation here. 6v and 2v, they're on opposite sides. And I also have negative 24 and negative 48 on opposite sides of the equal sign there. So again, when we get to this situation, we just have to choose something to start moving. It just needs to be one of the 4 pieces in the equation. But doesn't matter which one you move first. I tend to bring the variables together first. That's always my first move. And I always move them in a way, or I try to move them in a way, where I get a positive when I move it, if I can. It's not always possible, but sometimes you can do that. So if I have positive 6v and positive 2v, and I need to subtract one of them, because they're both positive, I'm going to choose to subtract the 2v. Because that way I end up with a positive 4v, because 6v minus 2v gives me positive 4. If I had subtracted the 6v, I still would have ended up with 4, but it would have been a negative 4v. Is that a problem? No. It's just a preference on my part that I like to try to end up with a positive number if I can. So 2v minus 2v cancels, and you get 48. All right, so now we're looking much more like kind of a regular two-step equation. So what's being added or subtracted on the same side as the variable? 24 is being subtracted, so I'm going to add 24 on both sides. 4v comes down. 24 minus 24 cancels out. And then we have negative 48 plus 24. Remember, subtract them. 48 minus 24 is 24. I have more negative than positive, so my answer will be negative. And then we're going to divide by 4 because we're multiplying by 4 here, so you're always doing the opposite. You keep going on that concept until you get the variable by itself. So you simplify, bring your variables together, your like terms together, and then start solving it. Addition, subtraction first, multiplication, division second. V equals, so we have negative divided by positive, so I know it's going to be negative. 24 divided by 4 is 6. So let's see if I can type in negative 6 correctly this time. Forgot to grab the negative there last time. All right. Ooh, so we're getting a little bit more involved here. Not harder, just a little bit more involved. That's the kind of the word I like to use there. Is it's giving us more steps to complete each time. But they're not difficult. It's just a little bit longer. So let me write this guy down here. Okay. So now we're going to go through and we're going to start to simplify. So simplify first, Pemdas, parentheses. So I'm going to focus on the left side and the right side. I'm going to do them both at the same time, but we're going to go through the order of operations for each. So first, let's do the left side here. We have parentheses. Let's distribute this 4. So 4 times v is 4v. 4 times negative 2 is negative 8. And then I'm going to bring minus 8 down. Equals, all right, now we're on the right side. We're still in parentheses because remember we're doing this kind of at the same time. We're simplifying. So we do have a parentheses here. We have negative 2 times negative 7v. 2 negatives make a positive. So it's positive 14v. And then negative 2 times positive 4, that's negative 8. And then minus 4v just comes down. That's outside of the parentheses, so it does not get multiplied. All right, now we're going to start to add like terms. I don't have any other multiplication or division I can complete, so I go to addition, subtraction. So we have 4v, negative 8, negative 8. Well, these are like terms. That's just 8 and 8. Be careful about that because I can already hear some of my students going 0. Well, they're both negative. I had negative 8 and I'm going 8 more negative. So I need to combine them and I get 16 and it's negative. Because remember, we're putting 2 negatives together. And I like to do money on this one too. If I spend $8 and then I spend another $8, I didn't spend 0, I spent 16 altogether. So sometimes money helps with that, just kind of making that association in your head. All right, so on the left or the right side here, we have 14v and negative 4. V, negative 8 just is all by itself. There is no other constant on the right side here. So negative 14v minus 4v, well, that gives us 10 because 14 minus 4, and then minus 8 here. All right, so now we've come back down to kind of more normal, what we've been looking at. We do need to bring those variables together. So we're in the solving stage now. We've simplified as far as we can go, so we're going to start to solve this. So I'm going to bring the variables together. Again, like I said, I like to try to move them in a way that they're positive. So instead of moving 10, I'm going to move the 4. it's a positive 4v, so I'm going to subtract 4v from both sides like this. So 4v minus 4v cancels. 16 comes down. 10v minus 4v is 6v. And then negative 8v comes, or negative 8 comes down, not 8v. All right. So now this looks, back to a two-step equation here. What's being added or subtracted on the same side as the variable? 8 is being subtracted. So I'm going to add 8 to both sides. We can subtract these, say 16 minus 8, because they're opposites. They are going to subtract, but I have more negative than positive. So it's going to be negative 8, because 16 is bigger than 8, right? Hopefully that makes sense the way I'm saying that, where we have more of one, more negatives than positives. Because 16, even though, yes, it's a smaller number, technically, if you're thinking of the number line, there's more of them. I moved farther away from 0 to get to 16 than I did to positive 8. All right, so 6v and then negative 8 plus 8, those guys cancel out like we wanted. We're multiplying by 6, so we're going to divide by 6 so that they cancel out. Negative 8 divided by 6. We don't want a decimal here. And I can even test that, because as long as it's a terminating decimal, they might be okay. But this is not going to be a terminating decimal because it's a multiple of 3. So I recognize that right away, that I know it's going to be some kind of repeating decimal. And they don't give me a bar over here to mark the repeating decimal. So I don't want to turn it into that. I want to leave it as a fraction. But I do want to reduce it. They both can divide by 2. So I can reduce these. Negative 8 divided by 2 is negative 4. 6 divided by 2 is 3. And that will be v. So I don't want to type it in as negative 8, 6, because it said simplify your answer as much as possible. And I can even show you, if I start typing in, if I do 8 over, oops, hit the backslash, so it gave me another bar there. But this is this part. It's going to tell me you have not simplified your answer. It's even going to warn me before saying that you're wrong. You're not really wrong. It's just not in the simplest form. So you need to go back and go, okay, it's 4 and 3, because I can divide both of those by 2. All right, a couple more of these guys. We are almost there. Okay, so now we have some fractions, and we learned in the last section how to eliminate these. So it's the way I prefer to do it. Instead of trying to deal with all of these fractions, I look at the denominators and say, what's the lowest common multiple? So if I count by 5s and count by 2s, I go 5, 10, 15, 20, 2, 4, 6, 8, 10. Okay, I've already found a multiple that works. 10 works for them. So I'm going to multiply everything by 10. Every single piece. So this guy's by 10, 10, 10, 10. So I'm multiplying every single piece. There's 4 pieces here. So now this one just gets multiplied. And this is multiplication, not a subtraction sign. Sorry, I just realized that looks a little subtraction. So negative 3 times 10 is negative 30u. Don't forget to bring the u. The reason we're multiplying by 10 on here is it's going to eliminate our fraction. Because remember, I'd have 3 times 10, which is 30, divided by 5, which is 6. I can also do the division first and go, well, 10 divided by 5 is 2, and then 3 times 2 is 6. So it just depends on which way you want to do that. It's not necessarily a big deal if you do the multiplication and then the division. So on this one, 10 divided by 2, that's 5. And then 5 times 3 is negative 15. So same thing if I had done the multiplication first. If I did 3 times 10, I'd get 30. Divided by 2, I'd also get 15. So either way, you get the same answer there. And then 10 divided by 2 is 5 again. 5 times 1 is 5. So all that does is it eliminates those fractions. It makes it much easier to look at without having to deal with fractions and then making them like fractions with, common denominators. Now I can just go through and complete the steps like I have on all the other problems, where I'm going to bring my variables together. So I'm going to switch over to, oops, I meant to click on this guy, not the color editor. So if I'm looking at my variables, I have negative 30 and negative 15. So they're both negatives. I'm going to have to add either one. Whichever one I choose, they're going to be added to both sides. If I want a positive answer, I'm going to take this 30 and I'm going to add 30 to both sides. So I'm actually moving it from left to right this time. Negative 30 to minus 30, well, that cancels. 6 drops down, and I have negative 15 plus 30. So remember, you can also look at it the other way and say 30 minus 15. Well, that would give me 15, and this is going right through here, so this is an equal sign. So it'll give me 15. I have more positive this time than negative. So it is a positive 15. 30 is bigger than 15, and it's positive. And then negative 5 just drops down. So now we're at our two-step equation part here, where we just need to say what's being added or subtracted to the same side as the variable. 5 is being subtracted, so I'm going to add. I have 1, right? 6 minus 5 is 1. Oops, this is supposed to be addition. So 6 plus 5 is 11 equals, I'm going to bring 15 down, so 15u. And now I'm multiplying by 15, so I'm going to divide both sides by 15. 15 divided by 15 cancels. So in this case, 11 and 15, there is nothing I could do to reduce those. It's just going to be 11 over 15. So that's kind of as best I can do there for the simplification. I can click this, or you can hit the backslash. It'll also put those boxes in there for you. So that guy should be good to go there. Yay! So definitely, I know the fractions can be a little intimidating there, but you can eliminate them. You can also go through and solve this using the fractions if you don't mind doing it that way. But I have most of my students prefer to get rid of that fraction if they can. All right, so for each equation, choose the statement that best describes its solution. If applicable, give the solution. So in this case, what we're doing is we're going back and we're kind of reviewing what we did in chapter 1, where we have 3 types of solutions. So the most common one is one solution, which is shown here by W equals or Y equals, meaning we know exactly what W or Y need to equal in order to make this equation true. It has a very singular answer, so we call that one solution. Sometimes, though, we get no solution or all real numbers. And if I go back, and I know I did this on the notes page in class, if we look at a coordinate grid real quick, when we're talking about solutions, what we're talking about is where does it touch the x-axis. That's actually what a solution means. So here's our x-axis, here's our y-axis, right? So when we have one solution, what it means is we had a line, and I'm going to do a different color here. So we had a line that crosses like this. And here's my one solution. So this means it crossed the x-axis one time. If we have no solution, what that means is, and I'll do a different color here, that means that it's parallel to the x-axis like this. It's never going to touch it. So it never actually crosses the x-axis. And it can be above, it can be below. It doesn't matter exactly where it is, as long as it never crosses this x line, this x-axis. And then we also have infinitely many or all real solutions, as it says on there. So I'll do this guy in pink. And what that means, if we're thinking of a solution, meaning when it crosses the x-axis, and it can be all real numbers are solutions, so I can pick any number I want. Well, that means any number on the x-axis would work, right? What that tells me is that it's on the x-axis. So the line is actually right on top of it. So this is just kind of a visual of what the solutions look like. This is when we see them. But we also want to be able to identify them algebraically. What do they look like when we actually solve a problem? So let's go through, and we're going to simplify these guys, because we do need to simplify them. They're not interested in what the actual answer is unless you get down to one single answer. But we do need to simplify them to see what exactly are we going to get when we simplify these. So if I go through and I do my distribution just like all my other ones here, I have 2 times W, 2 times negative 3, and then negative 5 just gets tacked on there because we haven't done anything with that yet. I'm going to distribute my negative 3 here. Negative 3 times W is negative 3W. Negative 3 times 3 is negative 9. All right, now our last step, we've done the distribution, which got rid of the parentheses, and that was our only multiplication. So now we are going to look at addition, subtraction, adding like terms. So I have 2w and I have negative 5w. They're opposites. I'm going to subtract. And since 5 is bigger, it means I have more negatives, so my answer will be negative. 3w minus 9. All right, so now we have a variable on both sides, just like we did before. So here's my two sides of my equation here. I have negative 3w, negative 3w. So no matter what, I'm going to add 3w. So I'm just going to go ahead and choose one of these guys. I'm going to add 3w from the left to the right. So now negative 3w plus 3w, that cancels. And I have with negative 6 equals, well, this also cancels. Negative 3w plus 3w. It's the exact same thing as this one over here. So I just end up with negative 9. So then we have to look at this. This is a little bit of a weird answer. Doesn't mean you did it wrong. This is actually one of the things we're looking for. Negative 6 equals negative 9. Well, that's not true. So we say not true. And what this means is no solution. It's kind of one of the weird answers, but it doesn't actually give us anything. That's not a real solution. Negative 6 does not equal negative 9. So we just simply click no solution there. Let's look at the second one here. And again, what that means is the line is not touching the x-axis in any way. Okay, so then we have 4y plus 1 plus 5, 6y plus, minus 1 plus y. Okay, so we're going to go through and we're going to start our distribution because we need to get rid of those parentheses just like we have in all these other problems. 4 times y, we get 4y. 4 times 1, we get 4. And then plus 5 gets just put on the end here because I haven't done anything with it yet. Now I'm going to distribute the 6. 6 times y, I get 6y. 6 times negative 1, I get negative 6. And then plus y. So that was our distribution, which got rid of our parentheses. And that was also the only multiplication we really had. So we need to start combining like terms. I have 4 and 5. Well, those are just regular numbers, right? I can combine those. 4 plus 5 is 9. So I have 4y, that just comes down, and I have plus 9. Equals, now on this side, my like terms are 6y and y. So I have 6y plus y. Well, that gives me 7y minus 6. All right. So now it's very similar to what we were doing before. We want to bring our variables together. So if I want to make sure it's positive, I'm going to subtract 4 instead of the 7. Again, I just prefer that positives, so I don't have to deal with that part at the end if I don't have to. 9 comes down. We end up with 3y here minus 6. Again, we're just subtracting there. All right, so negative 6, this is being subtracted from the same side as the variable, so we're going to add on both sides. 9 plus 6 is 15. 3y comes down. These guys cancel. And our last step here is we're multiplying by 3, so I'm going to divide by 3. 15 divided by 3 is 5. 3 divided by 3 is 1, which means y comes down. So this is a singular answer. This means that it crossed the x-axis. So we have a very, very singular answer here. We have a solution, which is 5. So I would check this box here. So one thing which they're not necessarily showing us on here, and I want to show you what it looks like. I don't necessarily have one to come up with a big problem off the top of my head like that, but I want to show you what it looks like when you come to it, and all real numbers are solutions. So if we had something like 4y minus 5 equals 4y minus 5. So once we get down to this step where we have two variables, one on each side, and we have a constant on each side. So I'm just kind of pretending like we've gotten down to a problem like this. Well, if we notice already, they're identical. 4y minus 5, 4y minus 5. So this already looks a little funny, because they're exactly the same. So if I start subtracting 4y from either side, I'm going to have 4y minus 4y, that cancels. And 4y minus 4y, that also cancels. So we have our numbers come down. This is another weird answer, but -5 does equal -5. So this is where you would say, okay, it's true. It's weird, but it's still true. -5 does equal -5, or whatever the numbers are, as long as they're equal to each other. So this is where you would click on all real solutions, or all real numbers or solutions. I might have also referred to this in class as infinitely many solutions or an identity, because it has a couple of different names there. But I want to show you what it looks like since we're not practicing one of those here. But no solution, it's one of these weird answers, but it's not true. All real numbers are solutions, meaning it's a weird answer, but it is true. And then one solution, meaning that we know exactly what the variable has to equal. We got down all the way to the end and we have, w equals a number, or like in the second one, y equals 5. All right. Let's go ahead and keep moving here. My goodness, this is going to be a kind of long video, but that's all right. Want to make sure we get through all these pieces. So an air traffic controller is tracking two planes. To start, plane A was at an altitude of, let's see, I'm going to go plane A, and I'm not real great at drawing planes here, but we'll go with plane A. I'm going to put A off to the side here, A. He was at an altitude of 970 meters. And plane B was at an altitude of, so here's plane B, and we were at an altitude of 1,438 meters. So a little bit higher there. Plane A is losing altitude at 17 meters per second. So we're going to go down. We're losing altitude 17 meters per second. So every second we go down 17 meters. Plane B is losing altitude. So we're losing altitude on this one too, but we're losing it at 26 meters per second. So we're actually losing a little faster on plane B. So here's my kind of picture. I like drawing the picture so we can see this is what's happening. We have two planes at different altitudes. They're both descending. They're coming down, but they're coming down at slightly different speeds. This one's a little slower because it's only losing 17 meters per second. This one's going a little faster at 26 meters per second. So for each plane, write an equation for the altitude of the plane after X seconds. So if we think about these guys, so let's look at plane A. It started at 970, and it's losing 17 meters per second, or for each second. So we'd have 17 times, and they want us to use X for seconds. So this is an expression showing plane A. This is where I'm starting. This is what I'm taking away for every second. Same thing for plane B. We say this is where we started. Now instead of taking away 17 meters per second, I'm going to take away 26 meters per second. So there are my two expressions. I just need to type these guys in. Make sure you type them into the correct spot here. They should, it should be plane A and then B, but, just make sure you're reading and putting them in the correct place, because otherwise Alex will mark you wrong because it's not the correct expression for the plane if you type them in the wrong spot. Okay, so then write an equation to show when the two planes would be at the same altitude. So that means I want this expression to be the same as this expression. I want them to be equal. So all I have to do is take the two and say, okay, well, I want them to be equal, like this. And if we solve this equation now, we'll know how many seconds it will take before they're at the same altitude. Okay? But it just says, write the equation. It does not actually ask us to solve it. So I can stop. I do not need to do this, and I can even cheat a little bit. I'm going to highlight this and go copy, paste, equals, highlight, copy, paste. So that was just my little cheat. I copy and pasted it. You can also just type it in there, and I can click check. So it did not ask me to solve that. But if we did go through and solve, if they said how many seconds does it take, for them to be at the same altitude, that's when we would need to solve. But all that said is write an equation. It's not asking me to go farther. Okay, one more here. We're almost done. Okay, so in this one, and I had accidentally typed one in here, and was messing around and hit check, so that's why you can see this incorrect thing. So ignore the incorrect bit for just a minute. We're going to work out the problem here. So it says the perimeter of a rectangle below is 132 units. Find the length of the side WX. Write your answer without variables. So they want to know actually how long the side WX is. Well, first we're going to need to go through and we're going to need to think about what does the perimeter of a rectangle mean. So if you didn't know that, you can always click on example. A lot of the time with these types of problems, they're going to tell you what these words mean. If it doesn't, you just may have to look it up. What does the perimeter of a rectangle mean? And in this case, what perimeter means, no matter what, is it's the length around the outside here. Okay? So if we know that it's the length around the outside, then we also need to recognize the fact that a rectangle has two short sides and two long sides. And the two short sides are identical to each other, the same length, and the two long sides are also identical, or the same length. So that means if the top is 3x plus 2, the bottom is also 3x plus 2, which means that I have two of these, 3x plus 2. So I'm just going to multiply by 2. You can also write it as 3x plus 2 plus 3x plus 2 if you want to write it that way. I need to add the other two sides here. So plus, I have 4x plus 1. This right side is also going to be 4x plus 1. So 4x plus 1. And that's going to total up to what they told me the perimeter is. I already know it's going to equal 132. All right, so now we're going to start simplifying here. So we have 2 times 3x, we get 6x. 2 times 2, we get 4. Don't know why I didn't draw that one. Plus, we're going to go 2 times 4, we get 8x. 2 times 1, we get 2. Equals 132. And if you notice, they're both being multiplied by 2. So you could have done back at the beginning, I believe, of this assignment. It's been a very long assignment so far. But back at the beginning, we divided a number away instead of distributing. You could have also done that on this one if you understand that method. So that would have been perfectly fine. But I like doing it this way because students seem to follow a little bit better on the same method as long as we're not switching it up. So now we want to combine like terms. So we have 6 and 8x. So together I have 14x. And then I have constants here. I have 4 and 2. So I can combine those as well. So I just combine them kind of in one step, but I'm showing you, with the underlining here, you can see the two pieces I'm adding. All right, so now we want to start solving. We have simplified all the way down to a two-step equation. What's being added or subtracted to the variable? Well, we're adding 6, so I'm going to subtract 6. And you get 14x, 6 minus 6 cancels, and you end up with, what is that going to be? 126, right? So we have 126, and oops. What is going on? 1, 3, 2. Sorry. My device over here was kind of messing up. Okay. So I'm multiplying by 14. I'm going to divide by 14. Divide by 14. 14 divided by 14 cancels out. And x equals, if I divide by 14, I get 9. And they did give me a calculator in here. So I can use this calculator and I can go 126 divided by 14 and it'll tell me that it's 9. Okay? So I get 9. This is not the answer. This is not what you want to type in here. And that was actually part of the video before, but I wanted to rewrite this one because it was just kind of a funny way that I had written it. So I was showing students, you don't want to type in 9 here because then it's going to give you, it's the wrong answer. 9 is just x. I want to know what the length of this side, WX, is. Remember, WX is the same length as YV here, or VY, if you say it that way. So I want to take that side, which is 4x plus 1, and instead of x, I'm going to plug in 9. So 4 times 9 plus 1. 4 times 9, I get 36, plus 1 is 37. So be very careful about what you type in there, Because yes, this is kind of part of the answer, this x equals 9. We needed it so that we could plug it back in at the end. So be very careful what they're asking you. Alrighty, well that was section 4, definitely one of our longer sections here, and I will see you in section 5.